Science and activewear. Impacts on the environment. What is activewear? Activewear is clothing used for physical activity, such as synthetic workout tops, joggers, or leggings. The activewear industry, especially women's, has grown exponentially in the past decade, despite COVID-19's global impact on production. Unlike other clothing industries, activewear continues thriving, with a global market size of $338.29 billion as of 2023. This trend could be due to athleisure, or the popularized category of stylish activewear worn comfortably and casually in non-athletic settings. Undoubtedly, activewear is excellent in aiding athletic performance or providing a practical, stylish look. While activewear yields many purposes and benefits, its downsides remind us that this industry's booming success also comes at the environment's expense. One environmental impact of activewear includes microplastics. When washing activewear, its particles interact with laundry detergent and water molecules. During this process, synthetic materials artificially produced through chemical synthesis produce microfibers, a type of microplastic, with every wash. A marine microfiber pollution study estimates that around 34% of all microfibers are in the ocean upon washing. Ocean Clean Wash claims these plastic particles from synthetic activewear contribute up to 35%, or over one-third of plastic in the ocean. Since microplastics are nearly invisible, detecting and cleaning them from the water is difficult. As a result, microplastics are often found in the stomach of sea animals. Marine life may face starvation and reproductive issues from the microfibers they consume. Not only does this influence the ocean and its inhabitants' well-being, but ours as well. The microplastics in seafood, part of our food chain, are detrimental to human health when consumed. Activewear's synthetic makeup leads to microplastics in the oceans, inducing numerous more environmental problems. Another harmful effect of activewear is the culture of fast fashion consumerism, creating more clothing disposed in landfills. For instance, fast fashion could be buying the latest trending activewear in excess. As it's usually worn to sweat in, activewear has a high laundering rate on top of its extreme consumption and disposal rates thanks to fast fashion. Thus, an estimated 75% of textiles manufactured yearly are discarded in landfills. In a landfill, activewear interacts with heat, moisture, weather, waste, and microbes, producing greenhouse gases while it never fully breaks down because of its plastic composition. 1 kilogram of clothing in landfills amounts to 3.5 kilograms of greenhouse gases. Activewear is typically made using synthetic materials or plastics such as polyester or spandex for desired properties like sweat wicking and elasticity. Likewise, these synthetic materials are made of fossil fuels, which are non-renewable, finite resources like petroleum. For instance, the synthetic PDO, propadiol, emits many greenhouse gas emissions and consumes non-renewable sources in its production. Activewear's use of synthetic fabrics is not sustainable for the planet as it exhausts limited resources and contributes to climate change with its carbon emissions and microplastics.
Moving on to an example of activewear. One type of fabric that has gained lots of popularity in the current economy is the Dongyoon Sorona fabric. Dongyoon Sorona is an eco-efficient fiber blended with plant-based fibers. Specifically, Sorona is 37% plant-based, usually corn, and compared to non-renewable fibers, it requires 30% less energy, which shows its significant benefit. Its unique molecular structure makes it an ideal material to apply to a wide range of apparel. Sorona fibers can be used on their own or blended with other synthetic or natural fibers to deliver a wide range of benefits to the consumer and the environment. For example, some advantages this fabric has over others is that it is more flexible, soft, and resistant to stains. Considering that Dongyoon Sorona is a fiber, it is typically used in the textile industry that includes clothing, building interior design, and carpeting. This fabric has offered spinners, mills, and brands a high-quality fabric that does not reduce the performance of its users, thus making this fabric an ideal choice for those wishing to be eco-friendly yet also wear good quality clothes.
Moving on to the brief history of why, how, and when Sorona was invented, in the late 1990s, the development of DuPont Sorona fabric was initiated. DuPont got the objective to provide consumers with a high-quality, eco-efficient product, which eventually led to the development of DuPont Sorona. This was driven by their main motive to create a product that not only served consumers effectively, but also prioritized environmental preservation. This began by harnessing the potential of the bio-based monomer BioPDO as the foundation for DuPont Sorona. This involved the process of harvesting feedstock and extracting glucose from various crops. crops. Drawing on over a century of experience in creating transformative textile products like nylon, DuPont utilized their expertise to revolutionize the world of fiber and polymers once again with the introduction of Sorona. Through this dedication to substantial innovation, DuPont aimed to make a positive impact on both consumers and the environment alike.
What makes Sorona's production so unique? It follows a biochemical synthesis to produce the 1,3-PDO monomers, in other words, a molecule that joins with other identical monomers to form polymers needed for making the fiber. Plant starch is used in place of petroleum for this process, eliminating the traditional PDO's great carbon and ecological footprint. First, yellow dent industrial corn is harvested, dried, then wet milled. Glucose or sugar is extracted from the corn. Next, genetically modified bacteria, a culture of microorganisms patented by DuPont Tate & Lyle bioproducts, is added to the glucose. A chemical process, fermentation, involves microorganisms anaerobically breaking down molecules. Similar to how alcohol is made, this fermentation takes place in a small flask. As the fermenting mixture grows, it is transferred to a seed fermenter, then a production fermenter. Precisely monitored under exact temperatures and conditions, the fermenting glucose is made in large fermentation tanks, towering 10 stories tall. Instead of the chemical synthesis in petroleum-based PDO, Sorona's natural fermentation process consists of the following. The patented microorganism serves as a biological catalyst. A catalyst is a substance that accelerates a chemical reaction, in this case fermentation, without being consumed in the process itself. This turns glucose into two monomers, 1,3-propanediol. This bio-PDO, made of corn glucose rather than petrochemicals, is then filtered to remove deactivated microorganisms, leftover unfermented glucose, and other impurities. To do so, it is passed through charged resin, attracting and removing salts through an ion exchange. Ions are an atom or group of atoms with at least one positive or negative electrical charge. The bio-PDO is distilled, turning it into a clear sticky liquid. Finally, TPA, terephthalic acid, is added to the bio-PDO to form a molecular bond for structure. Bio-PDO used in Sorona's fibers is now produced. It can be combined with synthetic and organic fibers. 37% of Sorona's polymer is made up of the renewable resource bio-PDO.
The main goal of DuPont Sorona is to reduce the environmental footprint of the textile industry. Due to this innovation, many new innovations have started to enter the market as well, mostly collaborating with Sorona, setting a trend to make eco-friendly material. This fabric is environmentally sustainable as it uses raw renewable material in order to make an item that can be used for a long time. This innovation ensures the fabric will do its job while also protecting the environment by using eco-friendly material, benefiting the global community and the users of the item. Additionally, the fibers are both compostable and biodegradable. As this fiber starts to gain popularity and increase in sales, it motivates other companies to introduce new inventions as well, which will further promote the idea of environmental sustainability, which is obviously a positive impact in society and the economy.
Sorona boasts several advantages in terms of its performance and positive environmental impact. To name a couple, its molecular structure is slightly similar to other thermoplastics such as PET and PBT, yet due to its zigzag molecular chain, Sorona has better elasticity. This means bio-PDO and Sorona can be stretched out with excellent shape retention, even better than spandex. This zigzag structure is similar to nylon fiber, enabling Sorona fabric to have an exceptionally stretchy quality. Moreover, Sorona's bio-PDO is a plant-based polyurethane chemically identical to 1,3-propanediol derived from petroleum. Therefore, it reaps the same and even better qualities as conventionally made PDO, only without the harmful effects petroleum leaves behind. From the extraction to production processes, bio-PDO generates almost 50% less greenhouse gas emissions and consumes almost 50% less non-renewable energy. Bio-PDO can be a blend woven with other fibers, synthetic or organic. It can be incorporated into a multitude of properties and functions such as UV protective or waterproof swimwear, denim fabric, outerwear, and even carpets or car parts, which Toyota uses in some of its car interiors.
DuPont Sorona fabric also presents some flaws and limitations. DuPont Sorona presents certain limitations while being a recyclable material. Firstly, it is not directly made from recycled materials, hindering its overall product efficiency. This limitation challenges achieving a more circular and environmentally friendly production process. Also, the recycling industry faces challenges in handling Sorona as numerous recycling industries do not have an adequate material to recycle DuPont Sorona that has a distinctive characteristic. The technology required for recycling Sorona is not yet fully developed, further complicating the the recycling process. To overcome these challenges, scientists are actively dedicating their efforts to finding effective methods for recycling Sorona and overcoming these limitations to enhance its eco-friendliness and promote a more sustainable future. Overall, it becomes questionable if DuPont Sorona is a good innovation or not. Ultimately, DuPont Sorona is an innovation that benefits both the environment and consumers. Environmentally, the Sorona fiber stands out for its unique biological manufacturing process. It utilizes 30% less energy and releases 63% fewer greenhouse gas emissions than Nylon 6, which relies on chemical processes. Additionally, as DuPont Sorona is a bio-based product consistent with 37% annual renewable plant-based ingredients, DuPont Sorona significantly minimizes the environmental impacts compared to other fabric types. Moreover, DuPont Sorona's eco-efficiency extends to its blend with plant-based fibers, which enhances its efficiency of a positive ecological footprint. For consumers, Sorona offers numerous advantages. Sorona fibers were softer than polyester and nylon, resulting in increased comfort for users. Additionally, its higher denier characteristic makes it easier to bend, improving softness and resilience for various materials made with it. Consumers prefer Sorona due to its effective performance attributes such as smooth texture, visually appealing appearances, quick drying properties, durability, stretch recovery, vibrant color options, easy care, wrinkle resistance, and moisture wicking capabilities. The combination of DuPont Sorona's environmental benefits and consumer-friendly properties makes it a worthy innovation. While it contributes as a solution for wide global issues, which is the environment, DuPont Sorona serves as a valuable contribution to consumers as it satisfies their preferences.
What implications could DuPont Sorona's eco-fiber polymer have on environmental and biochemical sciences? Sorona fabric is an example of scientific innovation with the environment in mind to develop an eco-conscious product. As the 1,3-PDO in the bio-PDO of Sorona's fabric is manufactured naturally, the science industry could look to expand on this concept, searching for more ways to replace highly resource-exhausting and carbon-emitting synthetic processes using natural materials to alleviate environmental stress. Sorona may inspire companies and environmental scientists to take on a more simplistic yet effective approach to improving environmental issues like fossil fuel depletion and microplastics, in the sense that we create natural, less harmful alternatives. As Sorona reduces reliance on petroleum, it would influence industries such as fashion, medical, or textile to pursue a greener carbon footprint by adopting bio-PDO or other scientifically driven tactics. This incentive calls for the collaboration of companies and environmental and scientific experts and would spark the involvement of more sustainable science-induced practices or inventions similar to that of DuPont Sorona's fabric. DuPont Sorona's bio-PDO fiber thus inspires cross-industry action in which solutions to similar global problems are formed by combining and developing both said areas. Although Sorona may not be the complete solution, this plant-based alternative to fossil fuel-derived PDO has a significant positive impact for the planet while expanding scientific applications to everyday products, bringing us a step closer to a sustainable circular economy.